Yes. The equation only works if the bar carries a pure torque, the section considered is far from load point, and diameter changes. Plane cross sections remain plane after twisting and radial lines stay straight. The, the material obeys Hooke's law, that's linear elastic, and every diameter rotates through the same angle, rigid rotation of section. So basically what this axioms is trying to talk about is that for this to be equation to be valid, then the substance, the material must obey Hooke's law, right? It must have a pure it must be a pure bar, right? It shouldn't have like some kind of splitting or hooves in them. Just be a single bar. Now let's look at example 1 to see how we can solve 1 or 2 questions here. It said a solid steel shaft diameter div, which is equal to 50 millimeter, and then the whole of this parameter are given, right? Now let's look at how we can solve this question together. So for that example, all right, from here we want to solve this. To get this, what and what is given? You are given diameter. Please be careful. Diameter is in millimeter, so we have to convert it from millimeter to meter. Of course, we know that 1000 meter millimeter is equal to 1 meter. So this is the same thing as saying 5 times 10 raised to the power of sorry. If we divide this, we are going to have 0.05 meters. So 0.05 meters. So what we are given here, we are asked to find the maximum stress. Just know T is equal to J equals since we are asked to find our shear stress, then we are going to use shear stress all over the radius. Was the radius given? Yes, the radius was given, but we were given diameter instead of radius. So this is our D. So to find R is equal to 0.05 divided by 2, which is 0.025. So this is our radius R. And torsion was given in tension. You notice everything is in meter. That's why I converted it to meter. Then we have that torsion, which is a torque, 800 divided by J. We don't know J, but see, if you look at the equation, you notice that J is a solid. This was a solid shaft, so for J is equal to pi d raised to the power of 4 all over 32. Yeah, that's basically what that is. So this is how we got it. J is equal to pi d raised to the power of 4 divided by 32. J is equal to this. We just substituted it because we found our D, which is our diameter here, to be 0.5. This was the radius R, right? So here we can't work with J because we don't know J, but for a solid shaft, this is the formula for finding J. So we now substituted it. Now we have to find the solution to it. If we did it correctly, we'll have this. So what we just need to do is to substitute for J into this formula. So let's move forward. And we see that T, just substitute it. Okay, this is the formula. T all over J is equal to the stress all over R. So we are looking for the stress because maximum shear stress, that's what they asked us for. So making this subject of formula, maximum shear stress is R times T all over J. So we just substitute. What was our R? 0.025 times our T, 800, right? That was our T, divided by J. Our J was 6.136 times 10 to the power minus 6. You have to solve that accurately. Then you arrive at your answer. So If we did that accurately, you have 32.6 megapascal. So that is for the shear stress. Now we were asked to find the angle of twist also. So the angle of twist. To find the angle of twist, we have to use the second relationship. That's a T over J is equal to G times theta all over what L, right? We're given the length of the shaft from here. You can see we're given the length of the shaft as 1.25 and we're given G as 80 gigapascal. So that means we are going to make angle of twist theta subject of formula. So at the end of it, we are going to have that theta is equal to T times L all over J times G. We just substitute, then my angle is my my torque was 800 sorry, 800, right, times the length was 1.2 meter all over my J, which we found here to be 6.136 times 10 raised to the power of minus 6 times my G. My G was 80 gigahertz, so 80 times 10 raised to the power of 9. If we work that accurately, we should have, let me check my calculator, we are going to have 0.119 rad. Then if you convert it, we are going to have 1.12 degrees. So this is how you calculate it. So you see the relationship depending on what is given in the equation. That is how you solve. We are going to move forward to the next